Welcome to my talk, GraphQL in Java World. Let's go for a dive. This will be a short version of my usual talk because I would like to keep it around 1 hour. All the things that I'm going to share with you here come from my own personal experience, so your use case might be different. So take everything that I say here with a pinch of salt. First of all, let me introduce myself. My name is Vladimir Dejanovic. This is my Twitter, my mail, my GitHub account and blog, if you want to follow me online or contact me. I'm part of professional IT scene since 2006. In other words, I'm getting paid for developing software since 2006. And over the years, I work on all kinds of projects, work in all kinds of programming languages, methodologies, like you name it, I did it. Also, I'm a founder and leader of Amsterdam Java user group, and beside this, I'm giving talks at conferences around the world. Also, I'm Oracle Code 1 star. But enough about me. What this talk is going to be about? Well, first I'm going to talk about GraphQL, what GraphQL is and what GraphQL isn't. After this, we're going to go for a deep dive and basically look into the GraphQL like through the code, because code is the best, right? So, what is GraphQL? I'm not sure about you, but whenever I don't know about something, and I want to learn more, I go on the internet and try to search for the answers, So, first time I heard about GraphQL, I did exactly the same thing. And the response, solution which I found was that GraphQL is a query language for APIs. Whatever that might be, right? So I didn't understand actually what this means, so I continue actually searching for more answers and reading more information, and then I came to a very simple conclusion, and that is that GraphQL is a specification, nothing more and nothing less. And this is very important for us as developers because we don't work with specifications per se, we work with implementations of a specification. So we need to be aware which implementation we're using, like if it implemented the whole specification or only the parts of the specification. Does it differ? Does it actually have some specific things and things like that? So that's an important thing for us, right? GraphQL actually consists of two big parts. First part is a schema definition language, where actually we can define how actually our API is going to look like, like how response is going to look like, request is going to look like, all these kind of things. And I must say that, once I saw all the functionalities and possibilities of this schema definition language, I was very pleasantly surprised because it was much richer than some other things that I used so far, like Swagger, Open API Spec, API Blueprint, and things like that. But we'll see that later in the code. The second big part of a GraphQL is a query language, and this actually is communication between the client and the server, and this is a very rich also part of a GraphQL, and we will also see this more later in the code. One thing that you need to be aware of is that in case of the GraphQL, schema is a mandatory thing, and for the people coming from the REST, in REST, basically, we had also had the schemas, but they were optional, so you could have schemas, but even if you don't have everything would work perfectly. In the case of a GraphQL, you have to have a schema. It's a mandatory thing. So there are two options that you can do, how you can do it. You could either first write the schema and then basically write the code that actually matches to the schema, or you can go other way around, basically first write the code, then from the code generate the schema. Whatever way that you choose, it doesn't matter as long in the end you have a schema, because schema is a mandatory. Reason why schema is mandatory is a very simple thing, and that this is the reason why. So on initial connection between the client and the server, basically the server will send back to the client the GraphQL schema, and in this schema it will say, okay, this is how your request should look like, and this is how my response will look like. Then the client should actually store some schema somewhere. Optionally, of course, it can store it somewhere, and before even sending any kind of request to the server, it can use this schema to actually validate if the query is correct or not. Because why would you send some query when you know it's not valid? Even if you're a naughty person and you actually force the client to send invalid schema, server is first going to actually validate the query according to the schema before doing any kind of work. So in the case that you send invalid query, it's going to send you error right away without you losing any CPU like cycles or anything. And this is a very nice thing. Okay, so now that we have like some at least general idea of what the GraphQL is, let's go for a deep dive. We're going to, in this basically code, I'm going to use a GraphQL Java, which is a Java implementation of a GraphQL. And like it always says, talking is boring, so let's look at the code. And just before that, let me just explain you a little bit what I'm going to show you. So in this code base, I'm going to pretend that I'm building some conference application for conferences, and every conference, of course, has an attendees, people who actually attend the conference. Then there's, of course, speakers, people who give the talks at the conference. And there's also the talks, right, that people either go to see or give. The code is already online, and you can actually check it on this GitHub account. And there's like multiple branches, basically, that you can follow to actually go through the code and actually see what are the changes. So here I already have like downloaded my initial code, and let's just look quickly what we have in the code base. So here basically we have like attendee, and attendee has, of course, the ID and the name. And you might see here that I'm using like annotation entity to actually say, okay, this is the database, and I'm using also Lombok with the data annotation, so that actually Lombok will generate all the getters and setters and all the boilerplate code for me out of the box. The next thing is, of course, we have a speaker. So again, the speaker has an ID, has a name, and a Twitter handle, and again we also have like entity and the data annotations to actually make sure that this all works perfectly. Then we have a talk. Sorry. And again, we have an entity in data annotations. Talk has an ID of a type long, title of a type string, and description of a type string. So the standard pages. If we check in repository, we will basically see that, of course, we have attendee repository, which extends JPA repository for the type attendee and ID long. And of course we also have like annotation repository, and in this case basically I'm using the Spring Boot, so the Spring Boot is actually going to like generate all code for me. Similarly, we have like speaker repository, which extends JPI repository, which again is for the type speaker and of type long, and again we have repository. And last but not the least, we have talk repository. Again, extends JPA repository for type talk, ID long, and we annotate the also with repository. So all standard stuff. Also, we have a service. Again, so we have attendee service. Basically, we annotate with the service again for Spring Boot. And here, basically, we have find entities for a talk. Like things that we will need later in the code. And similar to that, we have also speaker service and the talk service. So basically, all the boilerplate code is already done for us, so we can just concentrate on the GraphQL API. So for this thing, let me first show you actually in dependencies. So from a dependencies point of view, this is what we have for the GraphQL. These three things. So first we have of course GraphQL Java implementation. Then we have GraphQL Java tools. This is basically some helper classes and some other things that actually are going to make our life much easier and smoother. And also then we have GraphQL Java servlet, which actually connects our GraphQL Java code with the servlet code, so that we can actually very easily expose our GraphQL Java over the API using the servlet. So like I said, there are two ways that we can actually create GraphQL API code. One is basically we can go schema first, or we can go code first. I personally like much more like schema first approach, so I'm going to actually do precisely that. So I'm opening schema GraphQL. So I'm here going to define all the types that we're going to use. So we have type attendee, and then I'm going to actually define what fields this type has. And the easiest thing that you can do is just go to the Peugeot attendee, and you just do this. Just copy paste. And then we can say, okay, ID is of a type ID. and we have name, right? Name is of a type string. And that's it. So ID and a string are scalar types, and from the scalar types that are actually coming by default with the GraphQL, we have int, we have float, we have string, we have boolean, and we have an ID. ID is actually like a special type which actually says, okay, this shouldn't be read by humans because this is usually an ID of some element. In a nutshell, it's a string. You may also notice that I added this exclamation mark here, and this actually means that this field is mandatory. So this field always have to be present there. It can be done. So then we have type speaker, right? And again, we can just do the copy paste of a speaker data so that all the fields that we need. So again, ID is of type ID. Name is of a type string. And Twitter is also of a type string. Okay, and the last but not the least, we have basically type talk, and let's see what we have for a talk. Again, copy paste. I'll just copy these two. Basically, we have ID of a type ID, and then we have these two. It's a title of a type string, description of a type string, and that's it. So now we defined all the types. And how we actually expose this? Well, now we are actually coming to the heart of a GraphQL, where actually we say schema, and here we see query of a type query. So let me actually explain what I'm doing now. So in the GraphQL query language, actually the language which the client and the server use to communicate to one another, it consists of three big parts. First part is actually query, which actually means read-only. So here actually I'm defining my read-only part of a query, and it's going to be like only type query, and I'm going to define it as any other type, and let's say all talks, and it's going to return talk. So important thing to remember with here, query is read-only. So like you can call it any type that you can actually call it. You don't have to call it query, as long as you actually write the appropriate code in the backend, it will still work. However, if everybody uses the same names, it will be easier for next person to actually come and see it to understand it. Also, make sure that you don't change the data in a query, because the query should be read-only and it's going to be executed in parallel. So if there are multiple query requests going to your server, the server is going to expect that they are read-only and that they can be actually run in parallel. So make sure that you write the good code, because you're in control. Okay, so now that we have a schema, what do we do? How actually we connect to the code? So let's go basically to this Spring Boot application, starting application. Here we have some code which is commented. So let's uncomment that and actually see what is here. So here we're actually defining some bean, which actually is going to be some servlet registration. And if we check in the end, we will see that we are basically creating a servlet, and we're registering it to _/GraphQL endpoint. This is the standard way to actually how to define servlet in a Spring Boot. But let's see actually which servlet are we creating here. So here we're using the GraphQL Java servlet and the Java Tools helper classes to actually generate all the code in an easy way. So here I'm just saying, okay, simple GraphQL servlet, basically new builder. Then I'm providing here a GraphQL schema. We'll look into this later, and I say build, and that's it. So it's very easy. Like basically, the good people from GraphQL created all the boilerplate code for me. So the only thing that I actually need to do is actually create this method here, which returns the GraphQL schema. And here what I actually do, I say schema parser, new parser, then provide the file of my GraphQL schema to actually parse it. And then we say resolvers, I'll come back to this later, we say build, and make executable schema, and that's it. That's all that needs to be done. of course, we need also resolvers. So what's going to actually happen when we start this code is that GraphQL code is going to actually look at the schema here and going to say, okay, I need to type attendee, but I have a purge attendee with these exactly same names. So I can actually map them. The same I can do with the speaker, also I can do it with the talk, but I can't do that with a query. So actually, let's now create the class query so that it can actually do the mapping. Let's create a new package. Let's call it resolver. Let's add the class called query. Query. I don't want to edit. And let's implement GraphQL query resolver. This is important thing. I'll add required args constructor here, and let's add here private final attendee service, then let's say private final speaker service, speaker service. We will need them later. Private final talk service, and that's it. And then basically what we need is we need to add basically this thing here, right? All talks. So this one. So we need basically to have a method which is called public list talk. Let's import the class. It calls all talk. Doesn't take anything as arguments, and return talk service find all. That's it. So let's now actually inject it into our code here. So then basically what we need here is, let's pass here attendee service, talk service, and speaker service. And let's just do the copy paste here. Okay. Attendee service, talk service, and let's say speaker service. Okay. And now here in resolvers we can say new query. Let's import our class. Yes. And we have what attendee, attendee service, no, talk service, speaker service. No, I got the wrong order. Attendee, speaker talk. Attendee, speaker talk. Okay. So now it's good. So all is good now. So let's actually see if it compiles. So let's build the code. So in theory, everything should work now. We should have basically the simplest GraphQL API now up and running. So let's see basically what we have and what we can do with it. By the way, also I didn't forgot to show you one more thing, and that is like in dependencies here. I also have like this one, GraphQL, and like dependency from a GraphQL guys. I'm going to use this to actually demo the code. And make sure that you have this added only in development, so don't push this to production, and I'll show you the reason why. Basically now it's up and running, so I can go to the local host 8080 GraphQL. Let's make this a little bit bigger, and basically this is what the dependency gives me. It gives me a client that actually I can use in during my development phase to actually play with my GraphQL API and see if things are working good or not. So what I can do here, I can say query, and I can say all talks, and then I can ask from the all talks ID, and look, I have also autocomplete here, title, and I have description, right? And if I run it, I basically get some data back. Reason why I have here like autocomplete is because, like I said, client connected to the server and server provided the specification. So not only that I have like autocomplete out of the box on the client side, I also have a documentation here, which I can see for all the things, basically with what things I have, what type, and all those kind of things. First time, to be honest with you, when I saw this, I said, okay, like yeah, but this is like the simple rest, so what's the deal with this? Well, the one thing that you can get here from free is you can actually do the filtering. So for example, what if I'm interested only in the title, no other fields? Well, then I can just, ask only for the title, and basically that's going to be that. Done deal. Another thing that I can also do as a client is, for example, let's say I don't want to call this title, I want to call this my title. So I can actually rename this. Because here you can see data, in response I have data, and then exactly same format like it was here. But if I do it now, basically I rename this to my title. Also, maybe I don't want to have all talks here, but I want to call it talks. So I can also rename that. And again, the same thing. So I can actually, as a client, can actually like rename and actually model how my response is going to look like, which fields are going to be used there, which names, all those kind of things. Another very nice thing with the GraphQL, the fact that it's actually a specification, is that if I force actually client to send something which is invalid, like for example this, I will get the error in a certain format. And this is already defined and decided because, like I said, GraphQL is a specification. This type of error here is out of the box error that you just get. Of course, you can customize it, change it if you want, so you can work with it. Okay, so let's look basically now at some little bit more complex things. So what if we go back? Okay, so let me just kill this code here, and now what if we say, okay, like yeah, but let's like enrich the GraphQL API. So if I go back here to the schema, I can actually then add more stuff. So I can say all speakers with the speaker, right? Speaker. I can say all attendees with attendees. Okay. So actually, I can add this. So let's just add it right away into my query. It's going to take just a second, so let's just add these two things. It's public list, publicly speaker, all speakers, okay. Okay, then we see here return speaker service, find all, okay. Let's import the speaker. Then we have here public list attendee, all attendees, return attendee service, find all. That's it. Cool. But let's let's not step here. Let's actually let's do the talk. Let's add speakers. Speaker. So far what was happening was basically our GraphQL API wasn't doing a lot of fancy stuff. It was just basically fetching the POJOs and basically calling the getters on the POJOs, right? So this time, actually we want to now create a real graph between the talk and the speaker and create connection between it. But we don't want to change the POJOs, we want to actually make it in a more nicer way. So what we can do is actually we can create here a new class, and let's call it speaker resolver. No, talk resolver. Okay, cancel. It implements GraphQL resolver for a type talk. Then let's say required args constructor. Let's import the talk. So oops. Okay, so it works. So we need here private final speaker service, and now we need to basically add this thing from a talk. So speakers, which is going to return the array of the speakers. So if you go back here, we say public list speaker for speakers. This time we actually take as an input talk. So let's input the speaker. Let's input the list. What we're going to do now, return a speaker service, find all speakers for talk. And that's going to be it. So let's actually check if this is going to work. Oh no, my bad, I forgot to actually to add it also into here. So I also need to add resolver here. So let's say new talk resolver for speaker services. Now we can actually build the code. It's going to work. So what actually I did here is I say, okay, like, you know, whenever you basically need to resolve this field, the GraphQL will not know where to go for it, because, like, you know, it's not present in the talk as a getter. So then what actually GraphQL is going to do is going to say, okay, let's look at the all resolvers that I have here and see if any of them is actually a resolver for a type talk. And this is precisely what it is. So it's basically here we have a talk resolver, which actually implements GraphQL resolver for a type talk, which means whatever field the talk has and you have no clue how to resolve it, I will basically provide you with the code here. And again, we have exactly, you know, signature here, exactly the same, you know, like in the GraphQL schema, we have basically speakers. As an input, we get a talk for which we need actually to resolve certain field, and then we return back the list of speakers. Okay, so this one is up. Let's now start it. Okay, so now when this basically starts, we can go again back to the GraphQL and actually, you know, like, see if all is good as it should be eventually. Okay, so it started. Let's go here. Always remember that whenever you change the schema, refresh the browser, because the browser needs to get the new schema. So basically this time now I can just, you know, remove this field and I can say speakers, and then basically here I can say name and I can say Twitter, and that's it, right? And voila. So I didn't change the speakers, basically I didn't change the talk, but I get now information about the speaker which is connected to specific talk. So another thing that actually I can do here is I can say, well, maybe I don't want to have always the speaker. Maybe sometimes I want, sometimes I don't want to have it. So I can say here include if, and I say true, and then basically if I say this, then everything is still exactly the same like it was. However, if I change it here as a false, then there is not a speaker here. Okay, you can say, okay, this is useful, but again, then it means that basically we need to change the query, right? Well, not exactly. So I can actually, let's remove this here talks, and let's remove this one also. So let's create here as a query, we can add here talks, for example. And here I can say, with speaker, for example, with speaker, boolean, it's mandatory, and basically I put the right one. Okay, and then basically here instead of false, I can say this one with speaker. So now I can actually, just changing this value here, which is basically input parameter, I can actually change what I'm going to get here. And to do that, I need to use this part here, query variables. So I just go here, I say with speakers, yes, and here I can say true. Oops. I can say true, and I have it. I can change it here to false, and it's not there anymore. So you see now why, like I said, the query language is a very powerful thing in a GraphQL. You can do a lot of crazy stuff with it. Okay, so let's not go a little bit further. Let's see what else we can do with the GraphQL. So another thing that you can do with the GraphQL, which from my experience was not a very easy thing to do in the past, was to actually have an endpoint which is going to give you A or B. Especially if sometimes A and B are very different. Defining those kind of things in Swagger, OpenAP, and Spec and things like that can be very tricky. But here you can just say union, and we can call it person is attendee or a speaker. And that's it. And now we can actually use this person like any other type that we can use. And we can say here all persons, person, that's it. Again, we need to add this to the query, right? So it can actually resolve. So we can say here public. We're going to use object this time. Again, we have all persons. So we can say list, list one is attendee services, find all. Then we have list speaker. List two is speaker services, find all, cool. And then we can basically add list one, add all, list two. You can say return list one. In theory, this should work, but let's check. Because in theory and practice are the same, while in practice they are different. The reason why I used object in Java is because, again, like union can be anything, so it can be completely different types. In this case, I can find some similarities between the person and actually between the speaker and attendee, but in real life with the union you can just dump whatever you want to dump there. So let's see now when we actually start it, what actually we can do with this. We just need to wait, of course, for Spring Boot to start up, but we will get there. Okay, so it started. Let's go back to our query. GraphQL, we can just shut this again. Refresh. Oops, maybe read it. Okay, refresh. So what I can do now is query, and I can see here all persons. And now we have on attendee. We say name, and on speaker we can have a name, and we can have a Twitter, right? And when we run it, voila, we get here attendees, and we have speakers. If, for example, I remove this part, then basically I don't have anything, and then basically here I get speakers. So another thing that nice thing that we can do here with the GraphQL, especially with the union, is that we can actually define something called fragment. So we can say fragment. We call it my fragment on, let's say, attendee, and it's going to return attendee name. Name, cool. And then basically here I can say on, actually just say my fragment, and that's it. And when we run it, now we have like attendee name, attendee, and for a speaker we basically get another thing. So another very nice thing which comes with the GraphQL GraphQL query language for free. Okay, cool. So let's see what else we can actually do with the GraphQL. So another thing that we can actually do with the GraphQL is also like defined interfaces. So let's define it here. So I'm going to go on the top and say interface, and I say human human. What every human has? Well, every human has a name of a type string, right? So then I can say here attendee implements basically human, and I can say speaker implements human. One thing to remember is that, like in the case of the GraphQL, when you write an interface and you write some type which actually implements the interface, you need to basically copy all the fields from the interface to the type. It will not be automatically copied for you. So then we can basically here define some Pojo. Actually, like let's define some interface here, like called human. It will also perfectly work without the human. It can work also with the objects, but why don't use interface when we can? So implements human. Okay, it's human. Speaker also implements human. Okay, and then here, yeah, we can then also add here all humans. Human. Now let's go back to the query. I'll just copy this query. So here I'm going to say public list human. Okay. Like I said, I could also do this with the objects, and there wouldn't be almost no difference whatsoever. But let's just use it. So if we build the code now, let's build it, let's start it, and let's actually see what is the subtle difference between the interface and the union in this in this specific use case. Okay, so it started now, and actually it's compiled. Now let's start the code. As you can see, it's not very difficult thing. It's basically like GraphQL just provides you with a very the thin layer actually, which wires your basically Java code with the GraphQL schema. It doesn't really do a lot of magic, but it does a very useful things for you. So let's actually delete this, and now let's refresh the browser again. So now we can see query, and we can say all humans. And what actually I can do now is say name, and it works. If I change this from all humans to all persons, it will not work, because the person is a union and it doesn't know if it actually has a union person or not. So with the unions, as we said, we have to say on speaker name Twitter, and say on attendee name, and then it works with the union. The similar thing you can also do with the humans. So with all humans, again, it's going to work, but also like I said, like you saw, I can just emit basically the field that I know that is an existing interface and basically just use it right away. Okay, cool. So, like I said, like GraphQL, let me just kill this first. GraphQL query language consists of three big parts. First big part is a query, which is read-only, and I demonstrated it so far. But as we all know, the only thing you can do is only read the data, it's going to become boring very fast. So we also need some way to actually change the data. For changing the data, we are using mutations. And the difference between mutation and the query is, of course, mutation changes the data. However, mutations are going to be run in sequence, so one after another. So queries, because it's read-only, doesn't change the data, will be done in parallel. Mutation, because it's changing the data, is going to be run in sequence. So let's see actually how to implement mutation now. Again, we go back to our schema. Here in the we go back to the heart of GraphQL, which is called the schema. Basically, here we add mutation. Let's say mutation. And again, mutation is just a type like anything else. So from the GraphQL point of view, all types are equal. although some have like some special meaning for us. So in case of mutation, we can say, okay, let's add a speaker. We'll have a name of a type string. It's going to be mandatory, and we're going to get back a speaker. Okay, so what we need to do now is, again, create new class. We call it mutation. Again, it is very important that the class here and in the schema we use the same name, so that actually we can map them one to one in a very easy way. So GraphQL will be able to map them. So we call the mutation. Later, so implements GraphQL mutation resolver. So one thing very important here to see is, in case of a mutation, we're using GraphQL mutation resolver. So mutation resolver. In the case of a query, we are using query resolver. In the case of a resolver for a type, we are using just a GraphQL resolver with diamond operator for that specific type. So that's a very important thing to remember. Okay, so let's basically add here require our constructor. Right, final speaker service speaker. Yes, it was add speaker, right? Let me check. It was, yes, add speaker with a type. Okay, so we say public speaker, yes, add speaker, string of the name, and here we say return speaker service. Save speaker. Okay. Ooh. Okay. Then I need to create here a speaker. Speaker. Speaker is new speaker. Speaker dot set name. Name. Speaker. That's it. So. Okay. Yeah, we need to also. Okay. So now all is good. The last thing, like always, is to actually add the resolver here. So basically we can add it here. New speaker, no, new mutation. Yes, new, yes, speaker service, and that's it. So everything should work. Yeah, but like I said, let's check. Okay, so let's check. Okay, so let's see basically what we did. So the only thing that we did is basically in the schema we added mutation, right? Then we defined the type mutation with add speaker name, basically, which is going to return the speaker, and we define the speaker, mutation, which implements GraphQL mutation resolver, and that's it. And let's now start it. Basically, GraphQL mutation. We added the method of exactly the same signature as in schema, basically adding the speaker, add speaker, which takes parameter of a name of a type string, returns speaker back. We basically added the speaker service here, add mutation, and that's it. So let's see. Okay, so this one is started. So now if we refresh, basically what we can do here is query, so all speakers, say like name, right? Let's just check for the name. Basically we have a name here, speaker 1, 2, 3, 4. So now what we can do is say mutation, we say add speaker, name, let's say Oracle Code Live, and basically we get ID, name, you can say Twitter, right? Let's check. Okay, so we got it. Basically Twitter is null because we didn't set it. And if we see query, all speakers, and just see name, it still works. Perfect, right? Okay, so let me actually show you how we can make this code even easier and even nicer. So what we can do is, let's first kill this one. What I can do very easily is actually go here into the POM and uncomment this part here, which actually says GraphQL Spring Boot Starter. So this is basically the code which is going to allow me to run this same application in a much easier and a better way with the Spring Boot. So then I can go here basically, and I can just comment this that we did so far. I can go to the query. Basically I can remove this one and I can say component. Then I need to remove this final, and this final, and basically just add here at resource, okay, resource, okay, and then if I go to mutation, again the same thing, remove this component, that's it. Talk resolver, again I can just say component, resource, and that will be it. And in theory now everything should work. Yeah, close without wired, but yeah, let's mix a little bit. Let's check if everything still works. In theory, everything should still work. So with this code, actually why I'm doing this is to make my next step even more easier. And let's start this and see if everything still works or not. Unless I made some typo or something like that, it should all work. That's good. In the worst case scenario, I can always just jump to the branch where it actually has the code which works fine. Okay, so it started, and if I refresh, I say speakers, it still works. If I say mutation, mutation and speaker name works, ID name, and let's see, works, perfect. So everything still works, perfect, right? So like I said, GraphQL query has three big parts. Query, read-only, we did it. Mutation, I also demonstrated it. And the last but not the least is actually subscription. And idea behind the subscription is similar to the query. The only difference is that with the query, you fire a request and you get response. One response. While in case of the subscription, you fire a request and basically then you get back the continuous information about some data coming in and coming in and coming in and coming in, It just doesn't stop like that. You can think of it, for example, for a Facebook, the news feed, or like the stock exchange market, or currency exchanges, things like that. So let's see how we can actually implement that. Again, like always, we go schema first. So let's first basically define here type, and let's call a type score, which is going to be like, for example, title. Let's say it's a score of a talk that people can of course score it, and then basically it's going to be score itself. It's going to be int, and that's it. And then here we actually add subscription, and we're going to add subscription, right? And we're again going to define this as a type subscription. And we're going to say type subscription, type subscription is going to have talk score. Score is going to be score, right? Let's put just something like this. So basically we have it. So then what we need to do is actually we need to create a project like this, right? So let's create a project called score. Score, yes, cancel. I don't want to add it. I'm going to add here data from the Lombok. So I have to like put all the boilerplate code and things like that. So what I needed is private string title, and I needed private integer score, right? And that's it. So that is it. Then I need also to define the type subscription, right? Actually resolver for that one. So we go to the resolvers. I say new Java class subscription. Now what we're going to say is implements GraphQL subscription resolver. Again, we are going to define it as component. That's it. And we need to basically add the talk scores, right? Let's see. Yes, talk scores. Talk scores. So we say here public publisher of a type score. Talk scores doesn't have anything, or we can actually add the title string, right? Let's actually add some string here. So talk scores talk string. They actually know for which talk we're actually doing that. So it's a string talk. Okay, let me import score and publisher plus reactive streams. We're going to from reactive streams, and then we're going to go here and we're going to say observable score. No, not input stream. Observable score. Observable score is observable is equal to execution. No, observable create. Create. Okay, this is the wrong observable. Oh yeah, I forgot to add one more thing. Java. No, it is here. Reactive. Okay, yeah, I forgot to actually add. Yes, I see I'm missing something. So what I need to add, dependency, I need to add RxJava. Yes. Reactive, via reactive x RxJava 2, and I need to add version 2.2.3. Yes. So now all should be good. Okay. Another following. What? Okay, so now import class. Yes, now we have like good observable. You see, when you actually add a good import, then you dependency, then everything starts to work, right? So we need to create, and let's basically create it. Okay, so what we are creating here is okay. So we need to actually say scheduled executor server scheduler server is executors new scheduled thread pool. Let's go to thread pool for the one. Come on. One. Then we say scheduled at fixed rate, and let's say what we're going to schedule. So we're going to schedule this, and the rate. Oops, a second. And the rate which we're going to say is 0 to time units. Okay, time units seconds. Okay. I need this one. Yes, I need this one. And basically, here we're going to just create a score. So we're going to score s is equal to new score. S.set title is going to be. Oh, I call it here talk. It's not talk. It's title. Title. Did I call it here talk or title? No, it needs to be title. Well, it can also be talk. Who cares? Let's leave it with a talk. Talk, and the score is going to be set score. Let's say math at random. Yes, multiplied by 10. Yeah, something like that. Math random multiplied by 10. Math with floor, right? Floor, and then we can say. Okay. We can class to an int. No. We say integer. Yes. Value off. Yes. Will it work now? Let's just put 1, and I don't care at this point. Why is this complaining? Also not very off double. Oh. Who cares? Math random. Now you know how often I use math random. Let's say 10. Everything is 10, and I really don't care. It's not. On next. Yes. That's it. Now that we have this, now we can actually finish. So we see connectable, observable, connectable observable is observable. Share, publish, right? Then we say connect observable, connect. Then we say return. Connectable observable. Yes, connectable observable to flowable, and then we say the pressure. Let's say buffer. Yes, let's still go with the buffer, and that's it. So basically, this is a very simple thing. You know, it took me some time because of something with the math random, but I don't use it often. Basically, what the difference between the subscription and the query and mutation is that here we don't return the type, we don't return basically the list. Here we actually return the publisher. So first thing first that we actually need to create an observable, and in this case, like I just selected something that's going to schedule that in every 2 seconds is going to create a new score. Basically, I'm going to set the title and basically set a score, which I tried to be random, but I failed. Then basically from that observable, we are creating connectable observable, and we of course need to connect so that actually start getting some information. And in the end, from that one we are creating the flowable, so that we can actually create a back pressure. So that's the whole point. So a lot of code here basically for for a very simple thing, but what can you do? Sometimes you need things like this. So if we now actually compile the code and start the code, in theory everything should still work perfectly. And again, like with this one, is basically we covered all the three big parts of GraphQL, basically the query, the mutation, and subscription. Okay, so let's see. Everything hopefully will compile. I didn't do any typos or anything, we'll find out. Oh, it's already running. Okay, so maybe I started by mistake. Let's see if it actually works. So if I say here, okay, and we can actually also check developer how it's actually implemented. So the specification itself, when it comes to the subscription, doesn't really say how it needs to be done. So for example, like the query is done over the get and post, mutation is done only over the post. Subscription isn't really defined per se, at least it wasn't the last time that I checked. It might be different now. But what actually, like for example, GraphQL guys did from the Java implementation is that, and like most people, they just created basically WebSocket. So we say subscription, we say talk scores, talk, let's say my talk, and basically we get back the title, right, and we get the score. So when you basically run this, basically, as you can see, here I have a WebSocket, which is basically open, and it's every second basically I'm getting the new data. Unfortunately, you can't really see it because, well, actually, yeah, you can see it here. That basically we get new data back, but in this case, it's always, the same data. Okay, so let's kill this. So the whole point behind the GraphQL, and actually the best way that you can actually use the GraphQL, and most useful way that you can use GraphQL, is to use it in something like this. Basically, you have a client on one side, basically then you have a GraphQL, your client basically hits the GraphQL, and then you have all kind of stuff in the backend. Because as you saw, the GraphQL has a very, very powerful query language, it has a very powerful schema definition, it can do like a lot of stuff for you in a very easy way. And there's a lot of power in it. So through it, you can expose some different APIs, you can different application systems, databases, whatever. You can build anything that you want in the GraphQL. I saw some people actually using the GraphQL just to create CRUD applications, and in my mind, that is like a very simplified way to actually use the GraphQL. And maybe in those kind of cases, I wouldn't even use the GraphQL. I would just go with a simple REST. Why you go through all the trouble of actually adding something which has a lot of potential just to use the CRUD, but you never know. Okay, so this is all nice, right? But what also I didn't show you some other thing. Let me just show you that quickly. So what also I can do is, so here I can say in speaker I can say talks, and I can say, okay, because every speaker can give a lot of talks. So I can say here talk, and then I can say speaker resolver. New class speaker resolver. So implement GraphQL resolver for the type speaker. Okay, speaker. Then I can say here component. Okay. Okay, let's implement this. Let's say private talk service, right? Let's just put AutoWire just for fun. And then if we go back, what did I say? I say talk, right? So I say talk, okay. Speaker resolver Java. Resolver. Oops. speaker resolve Java, okay. Public, okay, list, talk, okay. And here we get, of course, an argument, we know speaker, okay. So here return talk service file all talks by speaker. Okay. So when I now build the code, basically what I'm be able to do is create a cycle dependency. And I'll also demonstrate that. So that's the whole point here. So basically what happens if we have a cyclic query? So basically what we have a query like this, like talk, speaker, and talk and title. And the reason is because here is like the cycle dependency, title. And let me demonstrate that now. So what actually can happen potentially is that, you know, like I can have like indefinite query. And the idea is, will that work? Will GraphQL actually say something about that or not? So if we have a query like this, so as soon as actually it starts, we will find out. Like I always say, you know, like never believe stuff, always test and see, you know, what happens. People will say one thing, but you know, when you run it, you know, maybe it will be a different thing. So it started. So now again, let's refresh. And then basically say query all talks, title, speakers, name, talks, title. Then here again speakers, name, right? Talks, title, and like I can go on and go on and go on. And will it work? Yeah, it will work. So basically, what happens in this case, we had a talk, right? And we created and we had a speaker, and then we from the talk created the connection to the speaker. So that whoever actually asks for a talk, he can actually also ask for a speaker, which is connected to that talk, and all information that actually speaker has. Another thing is then we created the connection in this case from the speaker to the talk, right? Which means that whoever actually has a connection to the speaker can ask for any field or anything that's connected to the speaker, including the talks. In other words, we created an infinite loop. So you can really easily create a cyclic dependencies in your GraphQL API, and you should be aware of that because, you know, my use case, basically my code that actually I demonstrate to you, is not production ready, of course. It's just a, you know, simple demo application, and at one point it will just, you know, explode. It will crash because for every disconnection, it's going to go to the database, ask for the data. There is no caching, there is no any kind of protection, which comes from with a very important point that you need to understand, and that is in the case of a GraphQL, client calls the shots. It's not like, you know, like in the classical REST APIs where actually we as a backend developers, we had the full control of actually what we expose to the users, in which way we expose it to users, how much we expose to users, all these kind of things. With the GraphQL, it's a different story. Because as you saw, like, you know, like client can actually decide, okay, which fields he wants, which fields he doesn't want. He can rename things, he can change things around, he can actually pass parameters which are going to, you know, in different way actually execute the queries. He can create, like, you know, like from the talk to the speaker and back. So there is a lot power at the fingertips of our users, and we need to be aware of that because again, people can by mistake or, you know, on purpose create malicious queries or like queries which are going to last for a very long period of time and take our servers down. So the question is then, okay, what do we do about protection from abuse? Well, there are a few ways that you can actually protect yourself, but again, like it also really comes back to which implementation you're using. Because GraphQL as itself doesn't really care about it, so it's up to you and your basic implementation to either see if some protection is present there or not. Some ways that you can actually protect yourself is you can use timeouts. Basically, you know, if some query is taking too much time, you just send to the client, okay, like error or something like that, say like you're taking too long time. This is easy to implement. However, the problem with this solution is that, you know, you're not going to protect yourself because your CPU and memory and network are still going to be consumed. The client will not be waiting for you, but, you know, you're still going to burn the CPU processes. What you can do is actually something better, but more complex to do, is actually calculate max query depth. So if I go back to my query here, you can see, okay, like I have like, you know, how deep is my query. And again, like I said, before any kind of query is being executed on a server first actually checks validity of the query according to the schema. During that same check, you can also say, okay, let's see, okay, it's valid, but now also let's see how deep it is. And if you say, okay, like maybe it's just too deep, then basically say, okay, like I'm not going to do it because it's going to be too deep, it's going to be too cost for me. Just send error right away. So it's a win-win. It's a better protection than a timeout. The problem with this protection is it's more tricky to implement. Some implementations have it already out of the box. Some have actually just the hooks that you can use to implement it yourself. The biggest problem with this actually protection is that it will not protect you from the width attack. So in that case, what you can actually do even better is to say, okay, what's the maximum query complexity? So actually analyze the whole query and then say, okay, this query is of this complexity. And then basically if the complexity is above some number, you say, okay, it's too expensive, it's too complex, I will not be doing that. It's a much better protection than the query of depth. But again, it's much more difficult, difficult to implement. Again, some implementations have some things out of the box that you just put some numbers there and it will calculate it all for you. Somewhere it's just the hooks that you need to do it yourself. Another problem with this protection is that you need to be actually aware of how certain parts of a query are complex, how to score them. Because if we go back to, for example, to my call here schema, when you see some call like this, it might be called to some backend system, it might be called to, it can just go being calling to the cache, or it can go like over the very slow network. So you need to be aware what's happening in behind to actually like resolve certain things. And the fact that you actually know the answer today doesn't mean that some person who actually is going to change something here or there will know it also in a good way, will know that actually they need to update the score accordingly. The best, but the most tricky actually protection to implement is just throttling, where actually you say for every single query, you provide certain amount of memory and CPU in so often, like basically, and then basically after some, and basically that's it. So again, in that case, if somebody sends like really crazy requests or something like that, basically their query is going to be very slow, and maybe it's going to be like killed, but at least it's not going to affect the rest of the system. The downside is it is the most tricky thing to implement. Okay, so the logical question that also came to my mind is, okay, like what about caching, right? Because again, if we go back to my example, which is very demo-like, there is no caching at all. And the question that I'm very often asked is, does GraphQL does any caching for me? The simple answer is no. GraphQL will not do any caching for you. However, good implementations basically either provide something out of the box that you can use, or provide you basically with some techniques and hooks that you can actually plug in a very easy way and basically add the caching yourself. So basically, and make your application much more resilient. The biggest problem basically with the GraphQL is that it is a very fluid thing. It's very loosely coupled, because when you look at the schema and you look at the fields, you just know that some resolver is going to be called. But again, you don't know if that's going to be called to just on a pod which is going to say, okay, give me the getter, or it's going to go to some database, or going to go over the network, or do some crazy calculation in the background. You never know. So that's why, again, majority of the implementations have some hooks that you can use for caching. Another also thing that I'm very often asked about GraphQL is, okay, what about authorization and authentication? Okay, does GraphQL cares about that one? Well, again, not really. GraphQL cares only about a few things, basically about the schema, about the query language, and how to wire basically your schema to your code, nothing else. Everything else it's up to you. You need to take care of it. Again, some implementations already have some things out of the box for you, but again, majority of them just have the hooks that you can very easily use to add your authentications, authorizations, and all those kind of things. Like for example, hiding the fields, visible to the users, and making sure that only, if you have certain credentials, you can actually access certain fields. Okay, so let us summarize now. Basically, we saw the GraphQL, and I think that now if somebody tells you the GraphQL is a query language for APIs, it will make much more sense to you than it did at the beginning. As you saw, GraphQL has a very rich schema definition language, and you can do a lot of crazy stuff with it. Again, I didn't show you all of it, because I try to be conservative on time. Also, GraphQL has a very powerful query language. Again, like, you know, I demonstrate to you like a big part of it, but again, not whole of it. So I really urge you to basically, you know, go and check more about the schema definition language or the query language or the implementations of GraphQL, you know, and things like that. This is basically all the resources. So that basically that I use during this talk. So there's basically the codes base format that I showed you, that I demonstrate to you. There's like very nice, okay, like, you know, like branches, so you can really easily like follow, okay, like how things become more and more complex, and basically they extend more. Then of course there's like the GraphQL org website with, you know, all information on GraphQL. There's also like GraphQL Java implementation and their GitHub account. There's a lot of nice things there, like guides, tutorials, documentation, and I really urge you to read it. There's like a lot of stuff there. Thank you very much. That's it. This is the end of my talk. I hope that you enjoyed it.